In this video, I'm going to show you an overview of MStar Post. I will begin by generating some output data and then walk through some basic approaches for visualizing and analyzing the output. Starting with a cylindrical tank, and I'm going to change the bottom to flat. I'm also going to recenter the Y-plane into the center of the model. And I'm going to add a simple moving body. In this instance, I will use a Rushton. Going to make the diameter slightly larger and get rid of the shaft. Then move it up into the center of the tank. I'm also going to add some tracers. I will inject the particles into the system using this spherical geometry. And I'm going to set it to shaded just so I can see it a little bit easier. I'm also going to up the number of particles to 100,000 and move it to the top of the tank. I'm now going to manipulate some of the simulation parameters, starting with the resolution. I'm going to increase it to 150. I'm also going to change some of the output data. I'm going to turn on the EDR as well as the vorticity magnitude. And then let's go ahead and run this model. One thing to keep in mind is that I don't need to wait for the model to finish running before opening it in the solver. I can go ahead and start running at MStar Post immediately. Here we have the post solver, and it's showing us the data that it has run thus far. Let's start looking at some of these buttons up on the top menu. We of course can open files as well as save them, and we can even save the state at a certain point in time. We can change the background, and why don't I just use this black one just to make it a little easier to see, but we have a lot of options there. Reset all of the visualization to turn everything back to its default settings if you feel like you've made a mistake. And this button's really useful because it lets me refresh all of my simulation data. If you remember, we've opened the post-processor before the simulation has finished running, and this will let us gather the new data and incorporate it into the model. So before we had 5 seconds of data, and I'm going to hit refresh and press forward, and now I have 6 seconds of the model rendered. It's really easy to jump to a specific timestamp. I just click this drop down and then I tap the number key on my keyboard for the number I want, and the model will jump directly to that timestamp. I can switch between 2D and 3D view, which will toggle me between orthogonal and perspective views. I like using orthogonal with some of these default angles. Let's start by refreshing the data and watching the animation play without any adjustments, just to see what's kind of going on. So now we get an idea of the velocity of the fluids and the particle motion. I'm going to shift to perspective view just to get a slightly different angle on the model. Now let's go through the options in the objects panel. Here we have the annotations, and in this instance, for us, we can see the origin of the particles. And one thing I should mention is that you can click on this little eyeball icon next to each object to make it visible or invisible. I also can manipulate this time text in the viewer, and I can choose which corner it goes to and how I want it to be displayed. Up next, we can manipulate the boundaries in the model, and these are the static components. So down below, I can manipulate some of the settings for these boundaries. So I can change the opacity from opaque to transparent. I can change the color. So I'm going to add some gray and turn the opacity all the way up just to show you what that looks like. One of my favorite things to do is to turn on the cull front face option, which turns all of the objects, surfaces that are facing me in the model transparent, but leaving them opaque in the background. Up next, we have the slice data. I'm just going to go ahead and turn off some of these slices that I don't need. These slices are all transient data, so why don't I go ahead and refresh the model, start from the beginning, and press play just to watch it. So I can see the model running and I can see the velocities in the colored areas. One thing I can do to make this velocity a little easier to see, and I can drag the slope all the way to the top left, which will give all of the fluid data some kind of color, getting rid of the transparency. I also can pick a color scheme for the data. I also can change the minimum and maximum of the model by dragging the sides of the color map to the left or to the right. So let's refresh the data and run it from the beginning. And as you can see, I have this pretty interesting visualization of the model now. I can click this button next to the map to reset the minimum and maximum to the data range. And with the next button down, I can manually set some custom values. And as a reminder, I can turn on and off the slices of the data using these eyeballs next to each of the objects. I have a lot of flexibility in choosing which values are displayed. So for example, I have velocity here, but I also can just look at the y-axis of the velocity. So maybe I'm just interested in seeing what is flowing up and down. I'm going to pick a different color just to make it easier to see again. And I'm going to reset the minimum and maximum values. This isn't quite right, so I'm going to manually set the range to -0.5 and to +0.5. So what these colors are telling me is the difference between the liquids moving up and the liquids moving down. Let's now look at the dissipation rate. And it looks like I've selected the wrong slice. So let me select the right slice and now choose to look at the dissipation rate. This is an example of data that would be really helpful to visualize using a logarithmic scale because we're dealing with multiple orders of magnitude. So we can turn that setting on with the checkbox beneath the color gradient map. Now our representation is more granular with respect to energy dissipation rates. That was some features of slices. Now let's look at the tabular data. Let's go ahead and look at the, here we have some basic data about the fluids, some integral output. So we have velocity, kinetic energy, and density. The volume doesn't change because we have a closed system. And on the bottom left, we can check and uncheck which data we are interested in looking at. I can X out of the individual plots if I want to see more or less of them. And this is basically how we create data plots in MStarPost. I can also view the source data in this table, and I can copy and paste this data into another program like Excel if I wanted to run some scripts with it. Let's take a look at the moving body data. Here this plot has the power numbers for our Rushton turbine, and it's getting the values that I would expect, about 5.3 or 5.4. Let's look at energy conservation next. It looks like the shaft power is within 10% or so of the total energy dissipation rate across the fluid, which means that the simulation is doing a pretty good job of conserving energy. We can take a look at the timing and evaluate what computational resources the model is using at what points. What we want to keep in mind is that the more physics we add when we start the simulation, the more data we will have to look at and play with in post. Let's take a look at the tracer particles that we added to the model. We had them all enter the model at the beginning, just kind of dumped in, which is why this data doesn't have much to show us. I can open up this other set of data, and this will track the nearest expected neighbor distance for the tracer particles we added, and we can see the expected value over time and compare it to expected values. As the model continues to run, we can see how the density function converges to expectations from statistical sampling theory. Let's go back to the 3D view and going to turn off the fluid, but turn on the particles so we can see them in action. All right, so now we have the particles in the system. They're starting to get dispersed, and we have a lot of options with how we want to look at and display the particles. Down here in the properties panel, I can change their size, their radius. I can also change their coloring to represent another set of data, in this instance velocity magnitude, so we can see which particles are moving how quickly. And I can change the shape of the particle even from 3D to a 2D surface. We will go further in depth with particles in another video, but this is just to give you an idea of the basics. These buttons provide further control over what we are rendering. So far we've been looking at 2D slices of the fluid. We select this other button to examine the complete three-dimensional flow field. Now let's look at loading in the 3D volumes. So this will load the volumetric data into the simulation. So if you remember back when we constructed the model, we chose to include certain sets of data, including the volume print interval. Now looking back at the rendering, we can change how the data is colored and displayed like we've done before. And I'm going to go ahead and turn off the particles so we can see it a bit better. And something to keep in mind with this kind of volumetric data is that the opacity mapping is going to be very important, because you're going to end up hiding things to be able to see things. I can use this shade option to give me a little bit more control over the depth and the contrast. So this is the velocity field. And if you remember, we also recorded the vorticity. So let's take a look at that data. And I'm going to adjust the color mapping a bit. And as we can see, some really nice definition on these trailing vortices off the turbine. So if you have a kind of tracer particle to help track mixing time, or as well as tracking the velocity, we can render all that data here. We will be talking more in depth about volumes in another tutorial. We can also export media renders for using to show to other people. So under File, we can save a screenshot, and this will just save a image, a screenshot of the current state of the model. So let's go ahead and save one onto my desktop, and I'm going to name it and hit OK. And here it is opened up, and it has everything that my viewer had in post. I also can export and save an animation. I'm going to choose what type of file I want to save the animation as. We recommend using an MP4 file, and you can also give your file a name at this point. I'm going to change the frame rate to 30 frames a second and let this render for me. While this is exporting, let's take a look at the data. Here's the basic file structure. These text files down beneath you can ignore. They are used for peer review scripts. The checkpoints are save points that I can use to resume the simulation at specific times. The output folder contains all of the output data. And so this is the data that I can look at in MStar Post or peer review. Then we have the stats folder, and this is basically all the text files that were used to create the data plots that we were looking at earlier. So we can use this data and analyze it in a different tool, for example. It looks like our animation has finished rendering. Let's go ahead and play it. So here's a fairly basic animation. Thank you for watching this video on the basics of post-processing in MStar CFD. Please continue watching other post-processing tutorial videos to learn about additional post-processing features and workflows. And don't hesitate to contact our support team with any questions.